In this lesson, we're going to talk about the solubility rules and learn how to identify a compound as either soluble or insoluble in water. This is a complete listing of the solubility rules. Note that you may see some variations if you look online with the different sets of rules. These are the rules that we will use for this course. When we look at these, notice that there are a set of solubility rules and a set of insolubility rules. For example, if we look at compounds that contain the group 1 metal cations, lithium, sodium, potassium, we see that they're always going to be soluble. Same thing for the anions, acetate, nitrate, chlorate, and perchlorate. They don't have any exceptions, so once we see those ions in a compound, we know it's going to be soluble. When we get down to the halogens, chloride, bromide, and iodide, most of them are soluble, but we see there are some exceptions. When we pair any of those halides with silver, mercury, or lead, we get an insoluble compound, which means it's not soluble in water. And for sulfate, we see more exceptions: silver, mercury, lead, calcium, strontium, and barium. For compounds that are generally insoluble, this includes things like carbonate, chromate, phosphate, and sulfite, except when they're paired with the group 1 cations or ammonium ion. Sulfide and hydroxides are generally insoluble, except with group 1 cations or ammonium or barium 2 plus. And in general, when we see silver, mercury, and lead, those compounds tend to be insoluble unless they're paired with one of the anions listed. At this point, we're looking at solubility as kind of a black or white. Either it's insoluble or it's soluble. We will learn later on that there are degrees of solubility, but that comes in a later course. Let's look at some examples to see how we apply these rules. Our first example is NaCl. Notice that we see the Na, so we have the Na plus ion in our compound, and therefore this compound is soluble because anytime we see the group 1 metal cations or ammonium in a compound, we know that it will be soluble. Next, we see potassium nitrate. We see both K plus, which is a group 1 metal cation, and NO3 minus, which is one of our soluble compounds, and there are no exceptions. Therefore, this compound is soluble. And we can apply either rule to determine the solubility of that compound. Next, we have lead nitrate. Once we see the nitrate in that compound, we know that we're going to have a soluble compound. Our next example is AgCl. We see the chloride, and we see that chlorides are generally soluble. However, this one contains silver, which is an exception to the solubility. Therefore, this compound is insoluble in water. Magnesium sulfate contains sulfate, which we see are generally soluble. We do not see magnesium as one of the exceptions, so this is a soluble compound. Our last example here is barium sulfate, and we see that barium is one of the exceptions. Therefore, this will be an insoluble compound because sulfates are generally soluble except when they're paired with silver, mercury, lead, calcium, strontium, or barium. Now let's look at some examples involving compounds that contain mostly insoluble species. Sodium carbonate has sodium in it, therefore it's going to be soluble. Although carbonates are generally insoluble, the presence of the group 1 cation makes this a soluble species. If I look at calcium carbonate, we see that carbonates are generally insoluble. Calcium is not one of the group 1 cations, or ammonium, therefore it is going to be insoluble in water. Magnesium hydroxide has the hydroxide ion, and those are generally insoluble. Magnesium is not one of the exceptions to make it a soluble compound, therefore magnesium hydroxide is insoluble in water. Barium hydroxide also contains the OH-, but we see that barium is an exception. Although hydroxides are generally insoluble, barium hydroxide is soluble in water. Silver nitrate, we see that we have Ag+, and those compounds are generally insoluble, but when it's paired with nitrate, that's an exception. So silver nitrate is going to be soluble. Lead chloride, we see that compounds containing the lead ion are generally insoluble. Chloride is not listed as an exception, so this is an insoluble compound. Is PbI2 soluble? We see that iodide compounds are generally soluble. However, lead is an exception. Therefore, this compound is insoluble. Is magnesium sulfide soluble? Sulfides are generally insoluble. Magnesium is not an exception. Therefore, this compound is insoluble in water. Is AgClO3 soluble? We see ClO3 minus as a generally soluble, and there are no exceptions. Therefore, this is going to be a soluble compound in water. Is calcium sulfate soluble? Sulfates are generally soluble, but we see that calcium sulfate will be an exception. Therefore, this is an insoluble compound in water. Is ammonium sulfide soluble? We see that we have ammonium ions, which make this a soluble compound, and there are no exceptions to that. Although sulfides are generally insoluble, ammonium is an exception, so this compound is soluble in water.